This is question number 27 from the 0222 Final Exam Review. In this question, we're given a formula, and then we're being asked to either evaluate the formula for a given value or solve the formula for an unknown value. So let's start by reading it. To convert a temperature, capital C, given in degrees Celsius, to an equivalent temperature, capital F, in degrees Fahrenheit, we use this formula. And there's lots of versions of this formula. This one involves a fraction. So your answers in my math lab would be you'd need to write them in fraction form, but on a quiz or a test, you can write decimals, whole numbers, fractions. It all goes on a quiz or a test. But on my math lab, since they're using a fraction, they'll want your answer in fraction form. Okay, so what is A asking us to find? It says find the Fahrenheit temperature that is equivalent to negative 20 degrees Celsius. So I'm going to start by rewriting my formula exactly as it was given to me. And then it's asking me to find the Fahrenheit temperature. I'm looking for F that is equivalent to negative 20 degrees Celsius. They gave me a C. So in this problem, I can find F. I know what F is. I just have to follow this calculation. And if I know the C value, I just plug it in, follow PEMDAS, and I get that degrees Fahrenheit temperature. So I'm just going to plug in the negative 20 where the C is. And of course, you can just enter all this straight up into your calculator, since your calculator is programmed to do order of operations. But make sure you're using your fraction button to enter the 9/5. By using your fraction button, it'll tell your calculator to keep your answer in fraction form. I will just note really quickly that 9/5 is a nice, pretty decimal number. So if you did divide top number by bottom number, you would get the decimal 1.8. And since it's a terminating decimal, you didn't have to do any rounding. You could, on a quiz or a test, rewrite that as 1.8 times negative 20 plus 32 if you were more comfortable with that. But again, on my math lab, you'd have to keep that in fraction form. So I'm going to do fraction form just to help you out there. So let's go ahead and multiply 9/5 times 20, and then we'll add the 32. Now, lucky for us, when we multiply 9/5 times negative 20, we end up getting an integer. There's not a fraction anymore. We end up getting negative 36. Then we'll add that positive 32. Now I'm adding amounts that have different signs. If it's negative 32 degrees outside and it gets 32 degrees warmer, I'm still in the negatives. I hit -4. And then I need to put units on this final answer. The units are degrees Fahrenheit. So I know that negative 20 degrees Celsius is equivalent to -4 degrees Fahrenheit. Now let's take a look at B. In part B, we're being asked to find the temperature in degrees Celsius, so we're looking for the C. That's equivalent to 122 degrees Fahrenheit. So we're given the F, so I'm going to plug in the 122 for my degrees Fahrenheit, and that's going to equal 9/5 times C, which I don't know, plus 32. So we're going to have to solve this formula for the variable C. And when we're solving, we need to ask ourselves, what's happened to the variable? And then how do I undo all of that? So let's take a look. Okay, so I've located my variable C, and according to PEMDAS, what's happening to it first? Well, according to PEMDAS, I need to multiply by 9/5 first. And then once I do that, I add 32 to that amount. So if we want to solve for C, we need to reverse all that. We need to do the opposite operations in the opposite order. So I need to get rid of adding 32 first. How do we get rid of adding 32? We subtract 32 on both sides. So I'm going to draw a line to separate the left side of my equation from the right side. Then I'm going to subtract 32 from the right. And I'm going to subtract 32 from the left. And that gives me positive 90 equals to 9/5 C, technically plus a 0, but we don't need to write that since adding 0 doesn't change anything. Okay, and now I need to undo the multiply by 9/5. So how do we undo multiplication? We divide. We're going to divide by 9/5. So I'm going to divide the right-hand side by 9/5, and I'm going to divide the left-hand side by 9/5. Now, 9/5 divided by itself is just 1. So that's going to leave me with a 1c on that left-hand side. Sorry, right-hand side. I can't get my left and right together here. So 1c, and that 1 is understood. It's implied in front of the variable c. We don't have to write it. If you just see a c there, you have one of them. So there's 1c there. And then in my calculator, I need to type 90 divided by 9/5. And again, I'm going to use the fraction button just to make sure that if my answer happens to be in fraction form, my calculator will automatically do that for me. But we're going to see here that we actually get a whole number, which is nice. We looked out again. So if you know how to do this by hand, you would change it to multiplying by the reciprocal and making the 90 a fraction by putting it over 1. But you don't have to do all that. You can just straight up type it into your calculator. And when you type all that into your calculator, you get 50. So the temperature in degrees Celsius is 50 degrees Celsius. So we just found that 122 degrees Fahrenheit is equivalent to 50 degrees Celsius. Okay, one more to go. Let's look at C. Okay, C is asking us to find the Fahrenheit temperature, so we're looking for F that is equivalent to 32 degrees Celsius. So this is just evaluating a function. We're given the degree Celsius. I can find what F equals by just following this rule and plugging in the degree Celsius. I don't have to solve. I don't need to do any reverse operations. I'm just going to plug 32 in for the capital C. And then you just follow order of operations. Now on this one, you're not going to get a pretty whole number, okay? So if you change 9/5 back to 1.8 and you multiply by 32, that's going to give us 57.6 plus 32. Now, if this is in my math lab and it's in the fraction section, it's not going to accept decimals. I would accept them on a practice test, a quiz. I would accept them on the final exam, but my math lab will count it wrong. So just to be safe, I'm going to use my fraction button on my calculator to enter the 9/5 times 32 to keep it in fraction form. Even though we wouldn't really talk about degrees in that way, I wouldn't tell you it's 90.5 degrees outside. Like, we don't speak that way, but my math lab is programmed to accept fractions in the fraction section. So I'm going to write it out that way. Okay, so let's type that in our calculator. Okay, so it gives us this hideous, ugly fraction, y'all. I get 288 over 5. Then I have to add 32. And again, I'm just going to put this in my calculator. I'm going to use my fraction button. Then I'm going to just add 32 to that. So I'm adding 32 to that. And I end up getting 448 over 5 degrees Fahrenheit. No one talks like that. So just for fun, let's change that back into decimal form. So let's go ahead and do top number divided by bottom number, or you might have a button on your calculator that changes from fractions to decimals, and that's going to give us 89.6 degrees Fahrenheit. So that's much more reasonable as far as a real life form of this answer, but they're equivalent. They represent the same thing, they just look different. So I'm going to go with this decimal answer here. There we go. We're going to pretend we're in the decimal section of my math lab, right? Okay, so that is question 27 from the review for the final exam. If you have any follow-up questions, just shoot me an email.